Hello again, I'm Eugene, and today I have this sheet of paper and another mathleague.org problem that asks the number of ways to shade in 4 squares in this grid such that the shaded region is a polygon. Y'all probably know what a polygon is by now already, but in terms of counting them, we want the shaded squares to be like next to each other like this. We don't want two different regions separated by a bunch of non-shaded squares. Otherwise, that'll be 2 polygons. And we definitely don't want scenarios like this, like where the self-intersection section means that this figure wouldn't be a polygon. Time to think about the number of cases that will happen. I'm going to put it in a little table because it's a lot easier to organize, especially for those nastier casework problems, because believe me, there are nasty casework problems. Okay, we can have the 4 squares be stacked up like this, and we get this eyepiece. So I'm going to go put that in the table right now. And then we can also put the 4 squares, condense them into a bigger square, which would result in this O piece, which I'm going to also put in this diagram. The rest of the cases, however, they're going to be a bit hard to keep track of. They're going to have to be in this quote unquote 3 times 2 area because of the limited piece count. We only have 4 squares, and the 2 times 3 area would have 6 squares. So we can consider the 2 squares that wouldn't be in there. Okay, they can all be in the same side and not be adjacent, the missing squares. We will result in this T piece like this. So we can draw this as another case. And then we can have the 2 missing pieces be adjacent to each other, resulting in this L piece and then this J piece. So let's draw these, this L piece and then this J piece. And finally, we can have these 2 be on the opposite side, like this S piece and then this Z piece. So we can have it be like this or like this. And you can check that these are all the possible cases because the rest will result in empty spaces or diagonals and anything that just doesn't work. Hi, many of those pieces look familiar. They do remind me of that one Battle Royale game where you play with those pieces that fall into place, if you know what I'm thinking. Okay, now it's time to think about how many ways we can tally up for each case. First up are the I and the O because they're going to be the easiest.
The I piece and the O piece are the easiest to count. Like the I piece, you can do 1, 2, 3, 4, and then 5, 6, 7, 8. And then for the O piece, you can do 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, I'm going to go record the results now. The long piece has 8 ways and the square piece has 9 ways. Now the rest of the pieces.
The rest of the pieces are going to be a bit trickier to count, probably because of spinning. Fortunately, I think I may have a good trick to count them. Hopefully, it'll be as good as spinning, of course. So, we know that all of them can fit into a 3 times 2 section. So, with some quick counting, we can see that there's going to be 12 of those sections. And, however, some of the pieces are going to spin and look different. Like, take this T piece, and then spin it 180 degrees, and it will look like this. How about this L piece? Yeah, it will look differently upside down, or this J piece and then turn it 180 degrees. But the S piece, take this, spin it 180 degrees, and it will basically look the same. It has 180 degrees rotational symmetry. And how about the Z piece? Yeah, it's going to look the same after spinning it 180 degrees. So that's something to keep track of in terms of counting.
Okay, so the T piece has 2 orientations, so 12 times 2 equals 24. Same thing with the L piece, 12 times 2 equals 24, and same thing with the J piece, 12 times 2 equals 24. The S piece has 180 degrees rotational symmetry, so because of that, we will just have 12 ways. Same thing with the Z piece. Rotational symmetry means only one orientation that will work because flip it 180 degrees and it will be the same. Only 12 ways. Okay, let's add them up. 24 plus 24 plus 24 equals 72, plus 12 plus 12 which is result in 96, and then add 17 from the I and O, and you will get an answer of 113.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.